In your study of orthographic projection so far, you have considered only three principal planes. You have learned to visualize an object like this book from the top, from the front, and from the side. But suppose you open the cover of the book part way. Now you do not see the true shape of the cover from the front. Nor do you see it from the side. To visualize the cover accurately, you have to look at the book from another direction. Or suppose you want to make a drawing of this telephone. You need a true view of the dial, of course. But the front view shows the dial foreshortened. That is, it makes the circle of the dial look flat. The top view also shows the dial foreshortened. And the side view shows the dial as a line. In order to see the dial in its true shape, you have to look at it differently. That is, you need a view made out here, as if you were looking at it from this direction. Since this view would not be the same as any of the principal views, it is called an auxiliary view. An auxiliary view will show the dial in its true shape. If you study the relationship of the projection planes, you will find auxiliary views easy to understand. Remember that the principal surfaces of an object like this are parallel to the planes of projection. You project the front view on the front plane, the top view on the top plane, and the side view on the side plane. And each view gives the true shape of one of the principal surfaces because the projection plane is parallel to that surface. These planes are the principal planes of projection. They are mutually perpendicular. That is, each plane is perpendicular to the other two planes. The principal surfaces of the object are also mutually perpendicular, of course. Suppose, however, that you want to draw an object which has one or more slanting faces. The surfaces are not mutually perpendicular in this case. If you use the three principal projection planes, as you have done with other objects, and project the views, you will find that the front view does not show the true shape of the slanting face. This happens because the front plane is not parallel to that face. Nor does the side view show the true shape of the slanting surface. This happens because the side plane is not parallel to the slanting face either. The way to get a true view of the slanting surface is to project the surface on a plane which is parallel to it. Therefore, you introduce a plane which is parallel to the slanting face, an auxiliary plane. Call the view projected on this auxiliary plane an auxiliary view. The auxiliary view will show the true shape of the slanting surface. Since you do not need the entire view, but only the slanting face, you can disregard the rest of the view. Call this a partial auxiliary. There is nothing complicated about auxiliary views. You simply put the projection plane parallel to the slanting face of the object. The auxiliary view and the top and front views, or as much of them as you need, describe the object completely. The side view is unnecessary in this case. The position of the auxiliary view on the drawing paper will be decided by the position of the auxiliary plane in relation to the principal planes. There are different kinds of auxiliary views depending on the position of the auxiliary plane. It may be perpendicular to the top plane, as here. Or the auxiliary plane may be perpendicular to the front plane, as here. Or the auxiliary plane may be perpendicular to the side plane, as here. Sometimes the auxiliary plane may not be perpendicular to any of the principal planes, as in this case. In the auxiliary view you have just been studying, the auxiliary plane is perpendicular to the top plane. It shows as a line in the top plane, and this line is parallel to the top view of the slanting face. But the auxiliary plane is inclined to the front plane and to the side plane. This kind of auxiliary view is called an auxiliary elevation. An auxiliary elevation can be projected on any plane perpendicular to the top plane. In fact, on an infinite number of planes perpendicular to the top plane, except those planes which give us the principal views. For this talcum can, an auxiliary elevation would show the true shape of each of these surfaces. An auxiliary elevation would show the true shape of these surfaces also. Once you understand auxiliary views, it is not difficult to construct them. If you study this object and its planes of projection, you will see that the dimensions of the auxiliary view can be secured from the principal views. The view which shows the slanting face foreshortened, here the front view, has one dimension, the height, which also appears on the auxiliary view. So in constructing this auxiliary view, you get the height from the front view. On the view which shows the slanting face as an edge, here the top view, the other dimension of the auxiliary view appears. Therefore, you can secure the second dimension for the auxiliary from the top view. In making the drawing, first construct the principal views as far as necessary. Then think of the relationship of the auxiliary plane to the principal planes. Imagine reference lines on the view which shows the slanting face foreshortened and on the auxiliary view. Then think of the views in one plane. The auxiliary reference line is parallel to the edge view of the slanting surface. Therefore, in making your drawing, construct reference lines, one on the view which shows the slanting face foreshortened, and another parallel to the edge view of the slanting face at a convenient distance. To get one dimension of the auxiliary view, draw lines perpendicular to the auxiliary reference line from the edge view of the slanting surface. Measure the other distances from the other reference line and transfer these distances to the auxiliary view. They give you the height of the piece, the height of the slot, and the hidden edge of the base. When you have strengthened the outlines of the views, your drawing is complete. Constructing an auxiliary view is no more difficult than drawing a principal view if you understand the relationship of the planes of projection.